Writing and graphing inequalities. Inequalities are really important. We use them all the time. You can see from this table that every time someone talks about is more than or at least, they're actually using inequalities. We have greater than or equal to, less than, and less than or equal to. And there's many ways of referring to these. Your friend is more than 5 minutes late. So we look at all these numbers below this and which ones could be true. We said they're more than 5 minutes late, so could they be 1 minute late? No, that's not enough. Could they be 2 minutes late? No. 3? No. 4? No, that's not enough time. We said they're more than 5 minutes late. Would 5 work? If they're 5 minutes late, is that more than 5 minutes? No. The ones that make it true are 6 and 7. If they're 6 minutes late, they are more than 5 minutes late. If they're 7 minutes late, they're more than 5 minutes late, and then so on. So we could write this as the inequality m is greater than 5. We graph these on a number line. So you draw a number line, 0, and you count 1, 2, 3, 4, 5, 6. And what we do, we need to put a circle at the point to distinguish the boundary between which numbers are true and which ones are false. So the boundary is 5. Anything less than 5 is not true. It's not more than 5 minutes. Anything more than 5 needs to be shaded on that side of the boundary because those numbers are true. And the circle that we leave at 5 needs to be an open circle because we don't include 5 itself. We don't put a circle on 6 because we have the fractions that are in between 5 and 6. Let's say they were 5.5 minutes late. That needs to be shaded because that is more than 5 minutes late. Here's one. X is less than 2. Well, what numbers could that be? Could that be 4? Could 4 be less than 2? No. Could it be 3? No. 2? Is 2 less than 2? No. Is 1 less than 2? Yes. So 1 works. Is 0 less than 2? Yeah. All these numbers this way work. So if we're going to put it on a number line, the boundary is 2. But we don't shade it in because 2 doesn't work. 2 is not less than 2. And we do not shade 3 because 3 is not less than 2. The numbers that make the sentence, the inequality, true are to the left. All these numbers need to be shaded in because they make the inequality true. X is greater than or equal to 1. So we want the numbers that are greater than 1, which are obviously these numbers, and it has a little line underneath that means equal. So it also includes the 1. So 1 should work, and anything larger than 1 make it true. Now if we do our number line, 1 is the boundary, and 1 is equal to 1, so we got to shade that in. And 2 is greater than 1, so we shade all the numbers on this side because they are true. They are greater than 1. A number C is less than -4. So we have to write our own inequality. A number C is less than -4. Now let's graph it. The boundary is always going to be that number in the inequality, so that's going to be -4. And we want to shade the numbers that make it true. Which numbers can C be and make it true? Is it the numbers on the right? Could it be a 2? Is 2 less than -4? No, it can't be that one. Let's try on the other side of -4. Is -5 less than -4? Yes, it's lower on the number line. So all the numbers to the left of -4 are shaded in. Now the question is, do we shade -4? Is -4 less than -4? Is -4 smaller than -4? No, so we do not shade it in. 4 times a number q. So 4 times a number q. So 4q is at most 16. Now this is where it's tricky. Most people look at that most and they think greater than. But when we really look at the whole sentence, we're saying that 4 times q is at most 16. It's saying that the biggest it can be is 16. That means that 4q really needs to be less than that. And because it's at most 16, it means it also can include 16. So it's actually less than or equal to. Now, just like solving equations, we want to get the q by itself. How do we get rid of this times 4? Well, we have to divide both sides by 4. 4 divided by 4 is 1q, and that 1q is less than or equal to 16 divided by 4 is 4. Now we graph it on a number line, and our boundary is 4. So we put a circle on 4, and it says q is less than or equal to 4. So we want all the numbers that are less than 4. So we shade to the left side because those are the numbers that are less than 4. Now the question is, do we shade the 4? Is 4 less than or equal to 4? Yes, 4 is equal to 4. So we shade the dot at 4. Here's a different one. Is x equals 8 a solution? A solution means an answer to x plus 1 is greater than 7. So they're telling us x is 8. Let's put that into the x. We've got 8 plus 1 is greater than 7. Well, 8 plus 1 is 9, greater than 7. Is 9 greater than 7? Yes. This is true. Last one. Is y equals 4 a solution to 7y is less than 27? Take that y, we want to substitute it in. We've got 7y, which means 7 times y, so 7 times 4 is less than 27. 7 times 4 is 28. 28 is less than 27. Is that true? No, 28 is not less than 27. It's false.